Today we will be solving radical equations. And so when we're solving radical equations, we're going to go ahead and isolate the radical. And so when we take a look at our first problem here, first thing I'm going to end up doing is subtracting this 10 from both sides. And so I look always at the sign in front of the term, and it's a positive 10, so I'm going to take it away from both sides. And so from this point, go ahead and rewrite what I've got. I got the square root of x minus 7 equals negative 2. Now, what we typically would end up doing to solve a radical expression like this is go ahead and square both sides to cancel out this radical sign. And so I'll go ahead and do that, and when I do this, I end up with an x minus 7 equaling positive 4 because the two negatives will cancel. So when I go ahead and take my 7, that's negative, and add it to both sides to do an opposite operation to solve for x, I end up with 11. So I did get a value of x, but whenever we square something on both sides or take a square root of both sides, we should always check our answer to make sure it makes sense. So let's take this 11 and let's substitute it back in for the x. So when we do that, we have this 10 plus, and then we go ahead and do 11 minus 7, and we see if it equals 8 or not. Well, 10 plus, and then here we have the square root of 4, and when we go ahead and do this work, we can take the square root of 4, which is 2, but when we add it to 10, do we get 8? No, we get 12. You see, I need to be able to subtract this 2 from 10 to get 8, but I didn't. It said to add, and so those numbers don't equal. And so what this means is we have no solution. And so we can use a symbol to represent that, and that's that 0 with a slash through it, or an empty set. And so we could have gone back up to the original problem. Now notice the original problem was when we subtracted the 10 from both sides, we had the square root of x minus 7 equaling a negative number. Well, we can't get a negative number underneath when we take the square root of anything. And so, at least in the real number system, we can't do that. So because of this, that also told us that we had no solution. So let's take a look at our next problem here. Here we've got x equals, and then the square root of negative 4 plus 5x. So the first thing I'm going to end up doing is I've got the square root symbol, I've got that isolated, the radical's isolated, so I'm going to go ahead and square both sides. So now I've got x squared equals negative 4 plus 5x. So what happened is the square root symbol canceled out when I squared it on the right-hand side. And so I go ahead and move some terms around. So whenever I've got a quadratic, the method I'm thinking of is using factoring. So I'm going to go ahead and subtract that 5x, add that 4 to both sides, and we'll rewrite our problem. So now I've got x squared minus 5x plus 4 all equals 0. And so I go ahead and factor, and this factors to an x minus 4 and an x minus 1. The numbers had to be the same sign because they multiply to make a positive, but they add to make negative 5, so that does end up working. So when I go ahead and solve, I get two answers. So remember, I'm using that zero product property, setting x minus 4 equal to 0, and I get 4. Set this x minus 1 equal to 0, I get 1. So I get these two solutions, but we want to check to make sure that they both work. And so it's always important. Just like when we checked over here, that one solution did not work. So let's go ahead and take those numbers, put them in the original equation. So 4 equals negative 4 plus 5 times by 4. And then we got to take the square root. So 4 equals, this makes 20 minus 4 makes 16. Yes, those two numbers do equal. So that does check off. And so we know 4 is a solution, but let's check the last one. So 1 equals the square root of negative 4 plus 5 times by 1. And so I go ahead and do some work there. Underneath the radical sign, multiply, subtract, I get 1. And so those two numbers do agree. So yes, these are the solutions. So that is my solution set. Taking a look at the next one, same sort of thing. We're going to square both sides because we have the radical by itself. And so when we do this, we have now 2x plus 2 equals not 2x squared, but 4x squared. Make sure you square both parts of that term there. So when we go ahead and move some terms around, I'm going to subtract the 2x, subtract the 2, and so that's how I'm getting negative 2x minus 2. So whenever you move something to the other side, you just switches signs. Well, when we're doing this problem, let's go ahead and take out that common factor. Let's divide by 2. So now I've got 2x squared minus x minus 1 equals 0. And so then now let's go ahead and try to factor it. We'll start with the 2x and the x to make 2x squared. And to make this negative 1, well, we'll do a 1 and a 1. To make it a negative 1, let's put the minus sign here, the plus sign here. So the factoring does work out, and I get these two answers, negative 1/2 and 1. So I subtracted this 1 divided by 2 to get the negative 1/2. Here I just added 1. But let's check those answers to make sure that they both make sense. And so let's take the negative 1/2 first and substitute in. So we got the square root of 2 times by negative 1/2 plus 2. And then that should equal 2 times by negative 1/2. So we go ahead and do some work here. We've got a negative 1 plus 2 makes 1, and the square root of 1 is 1. But over on this side, we get negative 1, and those two numbers do not agree. So, so 1 is not a or negative 1/2 is not a solution. So let's check to see if the 1 is now a solution. So now we're going to take that 1 and put it in for these two x's here that we have in our problem. So 2 times 1, and then over here we have 2 times 1 plus 2. Well, this makes 4, and this makes 2, and the square root of 4 is 2. So yes, this one does check out. So 1 is the only solution. So that's why it's important to make sure you check to see if you have solutions for both. Last type of this problem, and here when we square both sides, we got to be careful. So we have to, we're left with a 5x plus 4, and then on this side we have x squared minus 8x plus 16. So I had to use the FOIL method when doing this next problem here when I multiply the two binomials. And so I'm going to bring this 5x over, bring the 4 over, so now I've got x squared, and it becomes a minus 13x. Over here I subtract that 4, and I end up with a positive 12. And so now I'm ready to go ahead and factor. And so when I factor this, I end up with an x minus 12 and an x minus 1. And so when I go ahead and solve, I end up with x equals 12 and 1. So I added the 12, added the 1. But let's check our answers, make sure they make sense. So we'll try that 12 first. 5 times by 12 plus 4 equals, and then 12 minus 4. So when we do the work there, 5 times by 12 makes 60, plus 4 makes 64. And this should equal 8. And those two numbers do agree. So yes, 12 is an answer. But let's check the 1, make sure it is as well. And so we do 5 times by 1 plus 4, and see if that equals 1 minus 4. Well, I see right away I'm not going to get a solution because I do get a perfect square here. I get 9, but over here I get negative 3. I can't make the square root of 9 equal negative 3, so no, that is not a solution. So our only solution here is 12. Taking a look at our next one here, surface area of a cone can be found by using this formula here. If the surface area is 100 inches squared and the radius is 3, what is the height? And so what we want to do is just substitute the numbers that were given into our formula. So it says S is the surface area, so we're given the surface area here. So we have 100 equals, and then we've got this pi, and then it says the radius is 3. So pi 3 squared plus pi times by 3, and then we go ahead and substitute some numbers in there. So we got 3 squared plus h squared. So we go ahead and do a little bit more work. We've got 100, and this makes 9 pi plus 3 pi times by, and then we've got 9 plus h squared. So what we want to do is we want to get everything over to one side first. And so we can go ahead and either approximate this stuff now, so we can subtract this 9 pi from both sides, and I'll go ahead and approximate that 9 pi at this time. And 9 times 3 makes 27, so it's going to be close to 27. So when I punch it into the calculator, it makes 28.26. And then on this side, the 3 pi, when I punch that in the calculator, 3 times 3 makes 9, so I know it's close to 9, 9.42. And then I've got 9 plus h squared underneath the radical sign. And this all still equals 100. So I'm going to subtract that 28 0.26 from the 100, and I end up with 71 and 74 hundredths. And then equals, still have this 9 and 42 hundredths, and then the 9 plus h squared. And so I can go ahead, now I need to get rid of this 9 and 42 hundredths, so I'm going to end up dividing both sides by that number. So I'm going to divide by that 9 and 42 hundredths. So when I do that, I'm thinking of, okay, I've got a number 71, close to 72, this is close to 9, so it should be about 8. And so I go ahead and do the division, and I end up with this 7.61, and then the number kind of goes on for a while. And then this all equals, and then this is the square root of 9 plus h squared. So now I'm ready to go ahead and take the square, or to square both sides. And so I square this side and I square this side. Now, typically I leave this number a little bit longer. I left it as 7.61 and then a 5, 71125. And so when I squared this number, I ended up getting 58, and the number pretty close to that equals 9 plus h squared. So now I need to move that 9 over, and so I'm going to just subtract that 9 from both sides. And so when I do that, I end up with 49, and I end up having that equaling h squared. So now I need to take a square root, because I got h squared. If I just take the square root, I get a number. I get 7. I get plus or minus 7, really. But do we have a negative height? No, we don't. And so I'm going to use 7. So let's go ahead and plug in 7 into our equation there. So 100 equals pi times by the 9 plus pi times by 3, and then the square root of 3 squared times 7 squared. So when I go ahead and do some work there, this makes the square root of 58. And then I've still got this 9.42 and a plus sign and this 28.26. And then this all equals 100. So when I go ahead and do that work, I do get 100 equals 100. So it does check off. So 7 inches is our answer there. Well, taking a look at our last problem here, same sort of thing. We're going to go ahead and substitute some numbers into our formula. Remember, our formula goes this way. Area equals 1/2 base times by height. And so we're going to substitute the 15, because that's our area, and we're going to end up having 6 is our height, and so the height of 6, so I'm going to put 6 in place of h, but I'll move the h next to the 1/2 there, and then the base is this 3x minus 5, the square root of that. And so I'm going to take half of the 6, so that's 3, square roots of this 3x minus 5 equals 15. Well, when I divide 3 into the 15, I'm left with 5. And then I got this 3x minus 5. And so now I need to square both sides. And so when I square the 5, I get 25. And when I square the square root, it cancels out. So I've got now 25 equals 3x minus 5. So I subtract the 5 from both sides. I end up with, or actually I add the 5 to both sides. And I end up with a 30 equals 3x. So divide, I end up with x as 10. We'll always check the answer, make sure it makes sense. And so if we go ahead and do that, it should be 15 equals 3 times by, and then I go ahead and substitute the numbers in there, 3 times 10 minus 5. And so sure enough, when I go ahead and do the work, I end up with a 25 underneath the radical sign. And 3 times by 5 does make 15. So it does check out. So 10 is our value there, but it's asking for what the base of the triangle is. So we're going to go ahead and take that 10 and put it back into this formula right here. And so we do this square root of 3 times by 10 minus 5. So be careful. Just because you find a value of x doesn't mean that's your answer. You still need to do a little more work there. 30 minus 5, well, that makes 25. And the square root of 25, well, that's 5. So 5 meters is our base of that triangle. Well, those are the types of problems you'll see on tonight's homework. Good luck.